Yeah.
Alright, my observation.
Do they ramp up your shifts at co-ops?
Okay, so the first thing is understanding.
Big times, but not really because I hate co-op, but like,
Yeah.
for the money.
Yeah, it's actually the one that
So this should be on your page. Do we know the names of them? Do we know what to do? Like those kinds of things? Do we need to write those down?
Sure.
Vertical stretch. It could also compress, right, if it's less than 1. It would stretch if it's bigger, it would compress if it's smaller, and it could also reflect over the x-axis. B, first of all, I'm going to make the note, it has to be factored out, right? That's a big thing. To tell us anything, it has to be factored out. It would horizontally compress. If it's bigger than 1, it's compressing. Remember, it's opposite. And it will horizontal stretch if it's less. Okay, so that's opposite because it's a divider. So it's going to go in the reverse order of the multiplier on A. And you could also reflect over the y-axis. C would go left or right. It'll go left if it's a plus and right if it's a subtract, opposite.
When do they reflect over the axis? Like, what determines that in an equation?
Negative. If it's negative, these are
just a negative.
Yeah. If they're a negative. Okay, and D will go up or down,
Like here.
and that would be if it's plus or minus. Okay. If you need to write anything, I'm not going to write it, but if you need to make sure you're doing it in order, anything involving AB has to come before CD. So if you have to compress before a shift, right? Those kinds of ideas. Okay, then we have, what's that?
What's like the name of this equation?
Transformation?
That's just it.
Transformation. We probably also want to make sure we know this idea is a must have memorized. Okay, everything revolves around that, right? Revolves around that. Okay, this is another type of graph. So what did it mean in words?
Absolute.
Absolute value. So what are the big ideas with absolute?
Anything below 0.
Positive, if it's 0, it would stay. And negative absolutes change to positive. Then we had this. And there was a name for that one as well. Reciprocal. So we kind of broke it always down with heights of 0, do something. 1/0, so that is a asymptote. Heights of 1 and -1 stay, right? Invariant is the word. And then what, I don't know what you like to write. Big becomes small, or away from 0 goes towards 0, vice versa, right? So those are the big ideas there. Okay, then you had this one. The name of it, inverse. Also, another name or statement that could be made about it in the directions would be reflect over y equals x, the diagonal. So that was the idea. They just switch. Okay, so that was the transformation ideas. Okay. So then we have a radical. So a radical, so right now you should say, I know what a typical radical looks like. If I didn't do anything different to a basic radical, what would a basic radical look like? Did you think like that? It's a half of a parabola sideways, right? Okay, C and D. Your starter would move. Because of the C and D, your starting point would move. Your basic always has a basic pattern to it, which is 1, 1, 4, 2, 9, 3. But that pattern could change. What would an A do into this pattern? Timesing the up. And what would a B adjust this pattern by? It would divide the overs. Okay? So your radicals can reflect, right? So this is just the basic one, and then you could have radicals that reflect. Okay, sorry, this is the radical, and now this is a rational. So a rational is just any fraction, anything fraction. Okay, so I know that this is just an example, but we're going to write the general rules. So we're going to say you have NPVs. You can't have some values in fractions because the bottom is not allowed to equal 0, right? So you're looking, so for instance, this one has 3 and -3 are not permitted. So that would be a vertical asymptote unless there's a cancel, then there's a hole. So that's the rule. Bottom can't be 0, so it's a vertical asymptote unless there was a cancel, then now there's just a hole. Okay, now you have 3 rules here. You can either have a degree that's higher on the top, higher on the bottom, or same. So what do you know about what happens with those rules? Remember them. If the degree is higher on the top, it's just going to go. There's no rules. It's just going to go. If the degree is higher on the bottom, your number is just going to get smaller and smaller, like 1 over 10, 1 over 100, 1 over 1,000. You're just getting closer to 0. And if the degrees are the same, your y is going to equal some number and that's going to be from the division of the numbers, right? The coefficients, the leading coefficients.
By leading coefficient, that just means the coefficients of the
Highest degree. So if it's cubic, you're looking for whatever cubed on the top divided by whatever cubed on the bottom. Okay, now should we do sinusoidal? So sinusoidal would look like that.
This stuff all together.
Sinusoidal.
I mean, all the stuff we did before.
This last one was rationals. The name of that one was called rational. That one was radical, right? Radical things, rational. We've done sinusoidal. So sine x starts midline up. Cosine starts on a top, right? So you might get something that looks like this. So this would be called the midline. Which letter corresponds to that number? The D. The D is always the middle because you've moved it up something or whatever down. This space in this zone is called the amplitude. So from the middle to the top, or the middle to the bottom, whatever, should be always the same, right? It's called the amplitude. Which letter tells us about that? That is A. A period is considered when you go from a certain point until you get back to that point. And that is normally 2 pi, right? Normally. But what can affect it? Dividing by a b. Okay, and then there's a c where it's just, you have to figure out if it's moved left or right, your starter point, okay? Polynomials is another thing that we've graphed. So on this, I would probably say understand your basic shapes. So if I say we have an x cubed, do you know what that basic shape would look like? An n. Okay. Do I need to write the negative down, or are we okay to understand that? So if I go negative cubic, do you know what that just looks like? Okay. X to the 4th is a W. Negative x to the 4th. Okay, so those kinds of ideas. You should know your polynomials. I'm not going to write them all down. You have x squared. That's just a u, a parabola, right? You also have x-intercept rules. If it's a single x-intercept, you just go through it. If it is a double x-intercept, what do you do if it's repeated twice? You remember that one? You bounce off of it. And if it's a triple, you flatten through. You go through it, but you have to like come up, flatten, and then go through. And that was kind of the gist of our polynomials. What else have we got? Oh, exponentials and logs.
Okay.
We've graphed a lot of things. Am I?
Do we get this for the test?
No, but
Right answers,
we're
yes.
making a really good sheet here for studying.
I tried, boys.
Okay. Exponential. What would your typical exponential look like? That's an exponential. This would be if the base is more than 1. Okay, do you want me to draw it if the base is less than 1? Can you see it decreasing then? And when we do exponential, we always write our coordinates exponent, comma, results. Those are the coordinates that we always develop. Exponent, comma, results. Y equals A base to the B x plus C plus D. And then we have the log, which is the final, I think final, I'd have to think about this for a second. And a log graph should basic look like that. Y equals A log base. I don't know. I don't think I usually did B's on these, like the transformation B, so. And then we should write down our coordinate. Our basics for the coordinates are always results, comma, exponent. Okay, unit 1, 2, 3 was radical rationals, 4 okay, I think, anybody think of any other ones that I would have missed?